this video, we're going to talk about definite integrals. Definite integrals are going to be handled the exact same way as just taking the basic integral of any function. However, this is going to give us an exact value. Basically, graphically, what we're doing is we're finding the area under a curve here. So this is really the fundamental theorem of calculus when we start talking about integration. Now, it's pretty simple. Our bounds are going to be labeled by A and B here. And when we actually take our derivative, we're going to take our bounds and we're going to plug them in. And we're simply just going to subtract the values of those plugged in values to the function. And that's going to give us what the area under the curve is. That's going to be our definite integral. So when you're taking a definite integral, you should wind up with an actual solution for a number. So let's jump straight in. And look at this first example here. I know that when I start taking the integral here, we always increase our power by 1 and then take your coefficient and divide it by the new power. All right, so I'm going to have 8x squared, divide that coefficient by the new power, plus 5. And the constants are easy because we just give them a variable. We're going to evaluate it from 4 to 1. We can simplify this out. So I'm going to do that as I plug in my values here. So I have 5/3, 4 times 3 minus, 8 divided by 2 here is going to give me 4, and then times 4 squared plus 5 times 4. And I personally just always put them in brackets. You don't necessarily have to, but I do just to make sure that I'm distributing my signs and everything appropriately. So I have 5/3, 1 cubed minus 4 times 1 squared plus 5 times 1. And when we go ahead and we run that problem, you can throw that into a calculator or you can simplify it however you want. But you should wind up with an answer of 60 for that. And that would be the area under this curve here when looking at it graphically from the bounds of 1 to 4. Okay, so let's try another one. So this one's a good problem. I really like this one. Will give us a little bit more room to work with. But I always like to rewrite this so that I have 4. My bounds are 4 to 9. But I have x to the 1/2 plus 1/3 x to the negative 1/2 dx. Okay, and so now, again, when I start taking the derivatives, I know that the integrals, I'm going to take that power added by 1, which gives me 3/2, and I'm going to multiply my coefficient by the reciprocal. Okay, plus, do the same thing here. Negative 1/2 plus 1 gives me a positive 1/2, and then I multiply that 1/3 by 2 over 1 by 1/2. The reciprocal 1/2 gives me 2. So when we simplify that, let me clean that up a little bit. When we clean that up, we will wind up getting and plugging that in. We get 2/3 to the 9th to the 3/2 power plus, well, that's going to give me 2/3 to the 9 to the 1/2 power minus 2/3, 4 to the 3/2 plus 2/3, 4 to the 1/2. And when we go ahead and we evaluate this expression here, you should wind up with 40 over 3. And that's the definite integral. So again, taking that definite integral and applying the basic foundations that we know in finding an integral and then plugging in our bounds, it's very simple. So thanks for checking out the video. I hope it feels good. If you need anything, let me know, and we'll see you next time.